Today I'm going to be doing the practice problems for the College Algebra Unit 6 test. And these are kind of a selection of the more difficult problems from the test. And, obviously there's going to be your basic factoring questions, your quadratic formula questions, or which of these is the graph questions. But these are kind of representing some of the more challenging items. Okay, so we're going to start with an object's height, t seconds after being launched, is given by h of t equals negative 16t squared plus vt plus 184. After 8 seconds, the object hits the ground. What's the value of v? Okay, this is a way that we hadn't asked this question before. Okay, but what I'm going to do, I'm just going to kind of unpackage this. When it says after 8 seconds, the object hits the ground, well, that means that h equals 0, the height is 0 when t equals 8. So I'm going to say that 0 equals negative 16 times 8 squared is 64. Okay, so this is definitely a question for the calculator. Plus v times t will be, well, since t is 8, that'll be 8v plus 184. This won't be too bad, just provided that you've got one of our handy scientific calculators nearby. And negative 16 times 64 is negative 1024. So 0 equals negative 1024, 8v, and 184. Okay, so when I clear all of that over to the left side, it's going to end up with 840 because negative 1024 plus 184 is negative 840. Then I add that up to the other side, and that's equal to 8v. Divide by 8, and you get v equals 105. Which is answer choice A. I'll tell you, this is one of the, I'm pretty sure this is one of the items that was on the test that I took last year. And I went and actually took it. Okay, here we've got kind of an old-fashioned vertex of the parabola question, which I think this one also came from that same test that I took, that sample test. And so we know how to find the vertex of the parabola. That's x equals negative b over 2a, which is negative 4 divided by 2 times 1, which is negative 2. Okay, so right off the bat, I can eliminate a and c. And then to find the y value, I'm going to plug the negative 2 back in for x. So I'm going to square negative 2, I'm going to add 4 times negative 2, and I'm going to add 1. So this is 4 minus 8 plus 1. Okay, I've got negative 4 plus 1 is negative 3. So it's definitely not 1. Here we have one that we're going to solve directly, but the squared thing is a binomial. And that's probably something that we should have done on that day where we directly solved and used the quadratic formula. But, no time like now. So what we're going to do, you could square 3x minus 4, then subtract the 5, and then use the quadratic formula. But that would just be way too much effort. What I'm going to do instead is I'm going to take the square root of both sides. So I'll say that 3x minus 4 is equal to the square root of 5, or maybe the negative square root of 5. And then I'm going to add 4. And then I'm going to divide by 3. So I've got 4 plus or minus the square root of 5 divided by 3. And that's looking like answer choice A. Okay, and I think we've got another one of these coming up in a second. Now we've got one that's going to ask you about the relative widths of parabolas. And I think I remember mentioning when we were talking about the graphs of parabolas that, in the ax squared plus bx plus c, the a is determining the direction the parabola opens and its relative width. And that, if x squared was kind of the standard parabola, that 2x squared would be steeper, and that half of x squared would be wider. I think I remember mentioning. Maybe not in this section. But so for this one, I'm thinking, what's the difference between all of these? These all have, kind of a constant term as well to distract you. But all that really matters is the number in front of the x squared. Okay, so we've got x squared, a negative 10x squared, and a 1/10 x squared. All right, well, whether it opens up or down, that's not really impacting how wide or narrow it is. So from widest to narrowest, the widest is going to be this one, the one with the 1/10. So I'm going to say that h of x is the widest, and then regular x squared would be the middle. And then the negative 10x squared is going to be the narrowest. I mean, it's going to open downward, but it's still going to be really narrow. Okay, so if we're encountering one of these questions on the test or something, we're really just looking at the number against the x squared. And, there's nothing there, so we assume that's a 1, right? And 1 is nice and in between 1/10 and 10. Oh, okay. Another one that, I'm pretty sure y'all would be able to figure out, but we didn't do any that were exactly like this during the unit, so I just wouldn't want anybody to be caught off guard next time. Find the values of x that make the equation true. I'm going to do the one on the left. The one on the right is very similar to that one I did a couple of times ago, so I'm going to probably have y'all do that one on your own. All right, so find the values of x that make the equation true. The first one. Well, first we got to set this thing equal to 0, right? So I've got 1/4 of x squared minus 4x plus 15 equal to 0. And now, of course, we could use the quadratic formula here. There's nothing wrong with that. But I could also, I'm not good at factoring things when the leading coefficient is a fraction or negative. All right, I want it to be a positive integer. So I could just multiply both sides of the equation by 4 and kind of clear out that 1/4. So that would mean that, x squared minus 16x, and 15 times 4 is 60, would be equal to 0 times 4, which is just 4. And this is something that we can easily factor. No, 0 times 4 is not 4. That's 0. So this is something that we can easily factor. This is going to be two numbers that multiply to 60 and add to negative 16. That's going to be negative 10 and negative 6. And, okay, if these two things multiply together to equal 0, then either it's the case that x minus 10 is 0, or maybe it's the case that x minus 6 is equal to 0. This happens when x is 10 or x is 6. All right, now the one on the right is kind of similar to that multiple choice item up above, where the thing that was squared was a binomial. And so I want y'all to try that one on your own. And if you're watching at home, I would recommend that you pause the video because, really soon it's just going to pop up with the answer. Okay, there you go. So the first step is to kind of isolate the squared thing. That was what we did when we directly solved these quadratic equations that had no, middle term, so to speak. So I said that 2x plus 1 squared is equal to 13, meaning that 2x plus 1 could either be the square root of 13, or maybe it's the negative square root of 13. And then I'm just going to solve for x from there. It ends up kind of looking like a quadratic formula answer. All right, we've got another couple of problems that we're asking for the values of x that make the equation true. Now, on this first one, they want you to say that if two things multiply together to equal 20, then one of them has to equal 20. But we know that that's not true because it could be 5 and 4, it could be 10 and 2, it could be 40 and a half. There's really no saying it like that. The product property is only for 0. There's only a 0 product property. There's no 20 product property. So what we got to do is we got to actually FOIL this thing out. So it's going to be x squared, 3x, 2x, and 6 is equal to 20. And then we set it equal to 0, and hopefully we'll be able to refactor afterwards. I really hope. Okay, so since x squared, going to combine the like terms, and then 6 minus 20 would be negative 14. And that's set equal to 0. And now we're ready to factor this again. Yeah, there are going to be two numbers that multiply to negative 14 and add to 5. It's going to be 7 and negative 2. Okay, so x plus 7 times x minus 2 is equal to 0. Meaning that either x plus 7 equals 0, or maybe x minus 2 equals 0. Right, so just don't get tricked by this and fall into the trap of saying, well, either x is negative 2 or x is equal to negative 3. Because if you plug those in, you're going to be saying that 0 equals 20. And that's not true. Okay, those are not x values that make the equation true. Right. Then another one on the right with this squared binomial. It seems like I went for a lot of these on the practice set. So this one I'm just going to work quietly, and you can, follow along with me and just make sure you're doing it right. And then I guess the only thing that I would add to this one's pretty straightforward. The only thing I would add to that is that, when we say 5 plus or minus 5, you do 5 plus 5 or 5 minus 5. Because the answer choices aren't going to look like you're not going to see 5 plus or minus 5 in the answer choices in a multiple choice setting. It's just not going to happen. Okay, these are some, pretty safe looking inequalities, right? They look like something that we've done, but they are both kind of weird cases. X squared plus x plus 1 is not something that we're able to factor. Okay? And so I'm going to say if it's not factorable, then we're going to use the quadratic formula to try to find the zeros, and then we're going to, maybe make a number line or sketch a graph, depending on, which teacher you have for college algebra. And so I'm going to start by doing the quadratic formula. I'm going to say x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, 1 minus 4 is negative 3. And if I'm trying to take the square root of negative 3, that's not a real number. Okay, so this thing has no x-intercepts. And because it's positive x squared there, I know it's opening up. So I know that this is the type of thing that, opens up and has no x-intercepts. So it's going to look like that. And we're interested in where this is less than or equal to 0. Well, it's never equal to 0, and it's also never less than 0. So I'm just going to say, well, find the values of x that make the inequality true. There are no values of x that make the inequality true. You could say no solution. You could say no values of x. You could draw out the little circle with the slash through it, the empty set symbol. Basically saying that this is not going to happen. And then on the one on the right, okay, this one looks very similar, but less than 2, well, that might change a little bit because we know that the first step in these is setting the thing to 0. So that means that x squared plus x minus 1 is less than 0. That's x equals negative b plus or minus the square root of b squared minus 4ac is going to be negative 4, all divided by 2a. Okay, so this is negative 1 plus or minus the square root of 5 divided by 2. Okay. I'm going to make my little number line. or x-axis for a potential sketch of a graph. And this is negative 1 minus the square root of 5 divided by 2. And this is negative 1 plus the square root of 5 divided by 2. We know that, again, this is a parabola that opens upward. I'm going to do that. I'm going to say it's a parabola that looks like that. And we're interested in where this thing is, again, less than 0. So I know that the parabola is below the x-axis, so where y is less than 0, which is where x squared plus x minus 1 is less than 0. Okay, right here it's equal to 0, so we're not going to include those values. And then I'm going to conclude that this is true for x values between negative 1 minus the square root of 5 divided by 2 and negative 1 plus the square root of 5 divided by 2. Because if we go back to the x values that actually made this happen, it would be the x values along here that are between these two zeros. Okay, here we have the one that, I'm sure y'all didn't like it on the quiz, or we did in the lesson also. But we've got we've got a one solution or one x-intercept parabola, and we're determining where it's positive, negative, greater than or equal to 0, less than or equal to 0. And so I'm going to walk y'all through this one more time, because I'll tell you, this is coming back. Okay. But first, notice that y is equal to x minus 2 squared. And so when they say that x minus 2 squared is greater than or equal to 0, really what I'm going to say is that y is greater than or equal to 0. And if we look at all of the y values along this parabola, this is all y greater than 0. Here we have y equals 0. And then up here we've got y greater than 0 again. Looks like the video is lagging a little bit, so bear with it. It's okay. There it goes. Seems like it is finally caught up. Regardless, my point is that y is greater than or equal to 0 on this curve everywhere. So I'll say for every value of x, y is at least 0, or all real numbers make the inequality true. Okay, next they're going to ask us about where is y greater than 0. Well, y is always greater than 0 except for right here, where it's equal to 0. So when x equals 2, y is equal to 0. For every other x value, y is greater than 0. So it's everything except for x equals 2. So I'll say all x that are not equal to 2. Okay, this is like saying y is less than or equal to 0. Well, let's just break it up into less than or equal to 0. Okay, less than 0. I don't see the graph of this parabola ever going below the x-axis. So I would say less than 0 is never. Equal to 0 happens only at x equals 2. And so as far as less than or equal to 0, that's really only ever happening at x equals 2. So the answer is x equals 2. And then, okay, the last one is saying, where is x minus 2 squared less than 0? Well, that's like asking where y is negative, and y is never negative. Right here, at its minimum value, y is 0. It never goes below 0. Okay? So there's no value of x that you can plug in and get back a negative number. So I'll say no solution. But this should make sense, right? Because this is this thing that I've got right here. I'm putting a red box around. That's just the square of a number. If we square a positive number, that's coming back positive. If we square a negative number, that's also coming back positive. And if we square 0, that's coming back 0. Nowhere in there are we squaring a number and having it come back negative. Okay. And the last one that I'm going to do for you is going to be give a graph of this parabola. I'm just going to remind you how we're going to do that. First, we're going to start with a vertex. So we're going to say, for the vertex, we know that x equals negative b divided by 2a, which is negative 4 divided by 2 times 1. So that's negative 2. And then the y-coordinate of the vertex will be what we get when we plug in x equals negative 2. So negative 2 squared, 4 times negative 2, and then subtract 2 more. So I've got positive 4 minus 8 is negative 4, minus 2 more is negative 6. So the vertex is negative 2, negative 6. The y-intercept is f of 0. That's right. It's somewhere along this line where x equals 0. Wherever it is, it will have x coordinate 0. So x equals 0. F of 0. We're just going to plug in 0 wherever we see x. So that's 0 squared plus 4 times 0 minus 2. And maybe you just remember that this number is going to be the y-intercept, and that's great if that's the case for you. So it's 0, negative 2. So I'm plotting that point. And then what we're going to do is we're going to reflect, okay, across the axis of symmetry. We know that the axis of symmetry of the parabola is symmetric across its vertex. So right, there's going to be kind of this symmetry through here. And so if I went over 2 units that way to get to a point, I could go over 2 units this way and have another point that's on the graph of the parabola. Get rid of all that stuff and then connect the dots and make it the general shape of a parabola. We're not asking for 7 points like we did in Algebra 2, for those of y'all that were in my Algebra 2 class. Okay. We're looking for the vertex, another point, the reflection of that point across the axis, and the shape. And that is certainly a good enough parabola for our purposes. Right? We know that there's going to be a 0 between 0 and 1, and we know there's going to be a 0 between negative 5 and negative 4, and anything more accurate than that, we would probably need to use technology anyway. So that's pretty much all I've got for that. Okay, the last 2 sets of problems on the practice packet are pretty straightforward. This is find the x-intercepts of the parabola, which is where y equals 0, so we're going to set these things equal to 0 and solve. The theme of these 2 is factoring where the leading coefficient isn't 1. And in the description of this video, I'm going to have the link to the key to the practice set, but these are ones that you need to do yourself. Okay, I will do the one on the left, but I'm not going to do the one on the right for you. I'll only show you the answer on the key that you'll find in the description. Okay, so the idea is we're looking for 2 numbers that multiply to negative 30 while adding to positive 7. Okay, so it's going to be 10 and 3 somehow, so it's going to be positive 10 and negative 3. And then I take that 7x and I turn it into 10x and negative 3x. And you could turn it into negative 3x and positive 10x in the other order if you like, and you'll end up with the same thing. Now I'm interested in where this is equal to 0. And then I'm going to group in factors, so there's a 2x in common to these. I'm left with a 3x plus 5. Okay, negative 3x and negative 5 don't have anything in common besides the fact that they're negative, so I'm going to factor out a negative 1. Then I'm factoring out the 3x plus 5. And then I'm going to apply the zero product property that if two things multiply together to equal 0, then one of them has to equal 0. So either 3x plus 5 is equal to 0, or maybe 2x minus 1 is equal to 0. This is looking like negative 5/3. This one's looking like positive 1/2. And those are the x-intercepts. Okay, if you need practice with this, you should do the one on the right on your own, and then check the answer against the key. And then these last two, these are, okay, they want you to just factor and use the -1 or the 1 product property. But there is no -1 or 1 product property. There's only a 0 product property. So we have to set these things equal to 0, which is going to necessitate using the quadratic formula. And again, that's something that, you're going to need to practice on your own, so you can check your answer against mine on the key.